Dear friends, welcome to Hydrology Hub channel. Today in this lecture, I am going to demonstrate 2D flood modeling using HEC-RAS. So let's start. First of all, I'll open HEC-RAS. So this is the HEC-RAS window. Once you'll open, so you'll get the first window, HEC-RAS. So first of all, we have to create a project. I'll go to the file, new project, then give the name of the project. So here the project is going to be saved in the document file directory. Okay, so I'll give the project name as 2D flood modeling or river Betwa, or river name, or anything you can provide any name. Okay, so I've given here like this. Okay, now next step is that you have to go to the options, check the unit system. So unit system is metric system. Okay, we use the metric system, so I'll take the metric system over here. Okay, now next is you go to RAS mapper. So because I have to upload the digital elevation model DEM in the project, so I'll click over there. So you'll get the RAS mapper window. Here, before uploading the DEM, we'll set the projection system. I'll go to the project, set projection. Okay, so now you have to take the appropriate projection system of your DEM. So I have kept my DEM and the projection system here in the document directory as a DEM. So you can download this DEM from any website, wherever you want. Okay, so this way the projection system is set. Now next step is that you go to the terrain, just right click there, create a new RAS terrain. Now click on the plus sign and add the terrain. So here again my data is in here in the document in DEM. I'll go there and take the data. Okay, and then I'll just create on the create button. This so it says that the terrain completes. Close this one. So your terrain has come over there. Okay, now you can go to the map layer and right click there, add a web imagery, and you can add any of the imageries. I'll add here Google Map. This is being uploaded from the internet, so you have to have an internet connection on your system. Okay, so your Google Map has uploaded. You can see your Google Map. So this Google Map has come. Okay, from there you know that where is my river system. So you can see this is your river system. So here you can just mark. So you can mark appropriate places also in the river system. Okay, this way you know. Okay, now the next step, what I'll do, I have to create the geometry for carrying out the 2D flow modeling. Okay, so I'll go to geometry and click here, right click and create new geometry. So I'll leave the name like new geometry. Okay, so the new geometry is being created. So now here in the new geometry, again go to the right click and edit geometry. Okay, now you will see that once we click on the edit geometry, so a lot of options have come up. Okay, in the new geometry. So here in this case, for the 2D modeling, you go to the 2D flow area. Okay, just click the plus sign, expand this one. So you will find that there are number of options are there. So you will select the perimeter. Okay, so what we will do, we will just have the mark the perimeter of the for the 2D flow. Okay, 2D flow area. Now I'll start marking the 2D flow area. I'll take the river from this point to up to somewhere this point. Okay, so I'll mark the 2D flow area over there. Okay, just go on marking. I'll just mark over there. You see, this way you can go on marking the flow area. just use the mouse button. This way I have marked the perimeter. So now you can generate the mesh from this one. So I am taking the point spacing as 100 by 100 meter, okay, and default Manning's value. So I will take the default Manning's value as 0.025, okay, and generate the computation point. I will just click over there, okay. I can just go for the fourth mesh generation, close this one. So now the mesh is being generated, okay. Now we'll go to the boundary conditions, okay, over there. So here you can even edit this one also, okay. If you want to edit, if you feel that this my area is going outside of the dam, you can go edit feature, okay, go to the dam, select over there and just shift the features over there, okay. And you feel that this also is very large, so you can go and shift wherever you want. So this way you can edit. If you want, you can edit all these things over there, okay. I just want to edit all those things, okay, or I want to keep it here up to this point, okay. This way you can just edit your area, okay. This way you can edit all those, right. Now next part is that what we will do, we will go to the boundary condition, okay, and we will place the boundary conditions over there. So upstream and downstream. So upstream boundary condition it will place. So BC line it will make a line just outside this one. BC line I'll mark, write is upstream, and another we will make over there downstream. So what we did, we have marked the two boundary conditions line, upstream and downstream. So now stop this one, yes, save. I'll save this RAS mapper file and then I'll close. Now next step is that open the geometry data window, okay. I have opened this one. Here go to the file, open geometry data. The geometry data we have created we will open over here. So it has come here, right. So it is showing the your boundary line, okay, boundary conditions line, okay, and the mesh, okay. So you can see this is the your 2D mesh. So here, here is your 2D flow area. So if you have not created your geometry or your mesh over there, you can create the mesh again here also, okay. If in the RAS mapper you have not created, you can come over here in the geometry data and you can create the, or if you want to modify this your mesh size, suppose I want to modify from 100 to some other size, so I can go and just click here and then change these values, okay. Suppose I want to change this one to 90 by 90, so you can have here, again you can calculate here, okay. yes, right. And here you can also define the Manning's roughness coefficient, and then you can click on the fourth mesh generation. It can generate the mesh there. Okay, this way you can generate mesh. So there are two options. One, you can generate the mesh in the RAS mapper. Then if you want to have some changes and other thing, or you want to generate over here, so you can also generate this one in geometry data editor. Okay, so this your geometry is over. Now save this geometry, save geometry data. So I have saved. I'll close this one. So my next step is that I'll go to the unsteady flow data editor, click here. So first of all, I'll give the upstream boundary conditions. Okay, so here the upstream is my flow hydrograph. I'll provide the flow hydrograph. Just right now I am taking some hypothetical flow hydrograph. I'll just have a fixed date and time. I'll take suppose 1st September, and then time I take 00. So 00 hours it is starting, and hydrograph starts from 0. At 10 hour it is around 20,000 cubic, and again on 2nd September 18 hours it is 0. Okay, and just interpolate the missing values from other places. So just I made a hypothetical and hydrograph, and here I'll provide the slope of the river 0.0001. You can plot the hydrograph. So this is the hydrograph I have impinged into the river. So this hydrograph from the upstream is coming into the river. Okay, I want to model this, simulate this hydrograph. Okay, now you have to give the downstream boundary conditions. Okay, so downstream conditions are normal depth. Okay, so here in the normal depth again I will give the slope of the river 0.0001. Right. So now your data is complete. Okay, you have provided the geometry data, you have provided again the flow data and the boundary conditions. So now I'll go to the simulation or the run the model. Just click here, run the model. I'll give here plan 01. Okay, just click the radio buttons over there. Select the start date. His start date was 1st September 00 hours to end date 2nd September. It was 18 hours. So hydrograph was from 1st September to 00 hours to 2nd September 18 hours. Okay, I'll map output data. Suppose I want to keep the as smaller interval, around 20 minutes I want to keep. Okay, and computation interval 1 minute, 1 hour, 1 hour I'll keep and compute. So now once you click on the compute window, so now the computation will start. Just it will simulate all those things. So now you can see it has started the simulation. Now here you can see error has come, unable to compute phase tables. The terrain associated with the geometry does not completely cover the 2D flow area parameter 1. Geometry writer field error process geometry. Okay, now you have to see where is the error. So unable to compute the phase table. Okay, so you have to see you have to go over there and see where is the problem. You just see our data has come out of the dam. Okay, so these are the problem. You can just see. I'll add it here. Okay, in the geometry I'll edit the geometry, edit geometry. I have left it intentionally so that you can understand what type of problems come over there. Okay, so I'll go and edit over there and then edit this data. You can shift here or you can just go and edit. This point. Okay. Save. Now it has shifted. You just see here, you can see that now it has changed. Okay, I've seen that. Now it is over. Okay, now save this file, save this one, close. Now again I'll run the model. Okay, this is my run window. I'll compute. So you have seen that when I have given the boundary outside the dam, it has given the error, because when the boundary or the perimeter I have taken outside the dam, so there was no elevation and data was available. So that's why it has giving the problem. Okay. Now once I have corrected, so I intentionally have given the perimeter outside the dam so that you can understand what type of error may come if you run the model. Okay. So here now the model is running, it is simulating. So depending on the area, size of the area, how much area you have, what is your mesh size, so time of the computation depends on that. Okay, the smaller the size of the mesh, larger time it will take. Similarly, if your large area is there, so you are simulating a large river, so more will be your computation cells will be there. Okay, and it will take more time. So now it says the complete process. So I'll close this one. So now it's completed. I'll close this one and I'll go to the RAS mapper there, and you can see that here in the result you click over there, so plan 1 result has come. Here I'll go to the suppose depth, I'll select there. Now you can see how the water is flowing into the river. You can see. Okay, you can change the velocity of this animation by just clicking on this mouse, adjust this one. You can slow down this one if you want. Okay, so now I'll bring back this one over there and again animate. So here you can see how the animation is showing. Okay, then the flood hydrograph is coming into the river and how the water is moving into the river. So this way you can see the animation. So it gives the real picture how on the ground the water movements take place, what are the area where water is going fill. And here, because we have selected a depth, so once you click anywhere, just touch, so it will show the depth of the water at various points in the river. Okay, so here the 13 meter of depth is there in the river, and outside you can just see only 2.88 meter, like that, 2.85 meter. Okay, 0.17 meter, 0.53 meter. Okay, like this you have. Okay, 1.323 meter 2.12 meters like that. Okay, this way. So this is the way. So darker the color, more is the depth of the water. So this way you can see depth map, you can see the velocity map. Okay, what is the velocity of the water at different points. You can see the water surface elevation at different points. Okay, and you can animate any of the results. You see here, if I try to animate this result, this also you can animate. Okay, you can see the animation for the water surface elevation also. Okay, this way you can see the results in the RAS mapper. Okay, I'll stop this one and close here, and you can see hydrographs if you want to see. This is the hydrograph, you can see. Okay, so this way you can just see hydrograph. Then another thing in the RAS mapper itself, I'll show you. Here you want to know what is the discharge at a particular section. Okay, so here I'll just draw a profile line. Click here. This is the profile line I have marked over there, profile line 1. I can mark a profile line here. Okay, and so here I can see in the profile line, suppose I'll click here in the profile line, right click there, and you can see the plot profile line terrain you can plot. So you can see what is the terrain over there at this profile line and the profile line 1. Similarly, you right click there and you can go to the profile line time series of the flow. You can see the hydrograph over there, flood hydrograph you can find out. So this is the flood hydrograph you have at that point. Similarly, here if you want to see, pencil, in the profile line 2, this upstream, just upstream, you want to see the time series, you can, of the flow, you can see how the time series of the flow is there. Okay, so this way you can check the what is the flow hydrograph at different points, right? So this way you can see all the results. So if you have liked this video, okay, please share this one, subscribe the video, like the video, and press the bell icon so that you can get the notification for the new videos. Thank you very much. Thanks a lot for watching this video.